Lab 1. Becoming familiar with the software needed to print a COVID face shield and a PPE device. Hi, Joe Cerrone, and today I'm going to go through and show you how we're going to use CAD, AutoCAD, to be able to open a file and to then export that file into a program that we can use to slice the CAD file and prepare it for 3D printing. So we will be using these Bosch Dremel 3D printers, and here's an example of the printer that we'll be using. It's a 3D 45. It's basically enclosed. It has an RFID reader which will automatically tell what type of material we're using. It will give us feedback as far as what we're printing and how we're going to navigate through the printer settings with this LCD panel. And it has a single head extruder and a platen right here. It also has Wi-Fi and Ethernet and a USB port. There's a number of ways that we can print with the 3D 45s. For this exercise, we're going to go through and show you how to save it to a USB file that we can then insert into the machine. But they do have applications for cloud-based printing where we can actually remotely turn these things in. But due to some of the IT issues, we're not able to do that at this time. So we'll be turning these files in through the D2L course management system. Okay, so Lab 1 has a COVID face shield that was designed by Daniel Lawrence. He's an instructor in the engineering graphics area. And here's the file that we will use for that. We're going to open this file with AutoCAD, and so what I'm going to do is I'm going to click here and I'm going to say download. We'll download the shield. Now you will need to have AutoCAD installed on your system, and we've already gone through and talked about how to do that. If you do have any difficulty with that, you can instant message and we can walk you through that process. But for this lab, we're going to figure that you have the software installed. And so here's my AutoCAD software. If I take a look at the drawing, I already have one open, and I can open another one. And so what I'm going to do is open the one that I just downloaded, and I'm just going to go to my downloads. And see how it looks when I bring it in as a student. Comes in pretty much the same. And so as we look at things with AutoCAD, we want to familiarize ourselves a little bit with the user interface. AutoCAD has this ribbon across the top here, and in that ribbon you have different commands. And so we have our home screen, which has draw commands, modify, annotate, layers, a number of different things. And then we have these other tabs: insert, annotate, view, manage. And what we're going to do for this exercise is we're just going to look at the navigation. In other words, how do we zoom and pan and move around the drawing once we have a drawing file. And so we have this face shield, and if I turn the wheel on the mouse, I can change the navigation or the magnification level. And if I push the wheel on the mouse, I can then move around and take a look at the geometry. If I hold the shift key and push the wheel on the mouse, I can orbit the part. And so by holding shift and then dragging the cursor, I can see, oh, it's kind of neat. It's got my oakton.edu, so it's got a stamp on it. And then if I want to, I can let go of the shift key and the middle mouse wheel, and I can take a look at some of the geometry here. If I push the wheel on the mouse, I can walk around it. I can see that there are these tabs, and these tabs are going to be used to hold the plastic shield in place. And there's also this little slot here, which will hold the edges of the shield. And the shield will basically wrap around the front and then tuck into this other slot right here and be held on in place by these tabs. And if I want to see how the tabs look, I can kind of navigate my way around through it. Students can also take these parts, and if they want to, they can add something here, maybe like a piece of foam that might make it more comfortable. But it doesn't print foam, so we just have the basic geometry of the part. And And so once I have looked at the part and I'm happy with what I'm going to be printing, what I'm going to do is I'm going to export this as an STL file. And STL files are the files that are read by our slicing software, which is the Digi Lab 3D printing software. So what I'm going to do is I'm going to say File, and I'm going to export it. And so actually I need to hit this big red A, hit the Export, and I'm going to say Other File Formats, and I'm going to export the file as a lithography or STL file. And you're going to want to keep an eye on where you download this file or you export it to. I'm going to export it to my hard drive. I have a portable hard drive set up for this class right here, and I'm going to export it. And I want students to put their initials on this, and so I'll say JC-COVID-19 Shield STL. And it's going to go to this location, which is my portable drive. I will hit save, and then it's asking me to select solids or watertight meshes. And this is a solid model, meaning that it has volume, meaning we can slice it and we can work with it with 3D printing. So I'll select this, and then I'll hit enter. Once I have done that, it says that it found it and that it has created that file. I can take a look for it by going into the File Explorer, and then I can go and I can take a look at my drive, and then I can see where my STL file is. And so if I take a look here, here's my STL file right here. And what we're going to do is we're going to open that file with our Digi Slicer. So this file right here we can save as, and we can save that also with our initials. And we're really not doing anything other than putting it in your local drive. And so I'm going to save this also to that same directory. And this will save as an AutoCAD file. So there's different file formats that we're going to work with. This is a DWG file format or a drawing file format. Then we're going to go and we're going to open up our slicing software. Now the slicing software that we're going to use is this Dremel Digi Lab slicing software, and it's configured for our 3D printers. And so what we're going to do next is we're going to open that STL file by saying File, Open File, and then I'm going to navigate over to that. I'm going to locate the file, and I'm going to open that. And so here's our file, and the navigation on this works a little differently. If I turn the wheel on the mouse, we can notice that this will increase and decrease the size. If I push the left wheel of the mouse, it doesn't do anything. If I push the right wheel of the mouse, it will rotate. And so you can see that it is put it into the build area, and this is the platen of the build plate for the 3D 45. We take these out and we prepare them for printing, and then it shows us as we look at the interface over here that we can select materials, quality levels, and then all these different settings for being able to print a file. What I'm going to do is to orientate it in a manner that it will properly 3D print, because as it prints, it will print this little piece here and then keep going up in the Z-axis, and it can't print over error. So what we want to do is flatten this out or rotate it. So what we'll do is we'll click on that, we'll select the rotate command, and then what we'll do is we'll grab this and we'll drop this over 90 degrees. Once it's on the ground there, we can then check to see if it's going to fit on the build plate. And it appears to have a little bit of some interference because it is checkered. And so I'm going to bring this down slightly and scale it by 95%. Whoops. We can undo that and we can scale it. So we're going to scale this down to 190 millimeters. So we'll say 190. And that's just enough that it will fit onto the 3D printer platen. Once we have done that, what we're going to do is we're going to take a look at some of the slicing tools. We're going to set this up for PLA, and so our material here is going to be this Dremel PLA, which is polylactic acid, and we'll go through some of the materials in the readings. We'll also be able to set up the slicing settings, and the slicing settings for this will be to be able to build this in 0.3 millimeter layers. And so as it slices it, it will slice it in this increment. The higher the quality, the more fine the slicing is. And for this exercise, we're just going to go with a low quality and take a look at what we're going to get with it. We can take a look at some of these other infill and other material specs by expanding and unexpanding some of these areas. But for the most part, we're just going to look at our build plate adhesion. We're going to use this as a skirt, and we're going to enable support material. And by generating support, what that means is that it will have a little bit of area underneath that part that will then allow us to take a look at it. Now, when I set it up to generate support, it looks like I'm going to have to make it a little bit smaller. So what I'm going to do here is I'm going to go back and click on it, and I'm going to go and bring this down to 185 millimeters. Okay, so there we go. And now as we go through and work with this, we can then have it generate the support material that's required for this. We'll look at the build plate adhesion, which is going to allow it to hold it to the plate. And that's pretty good for right now. We don't necessarily need to go through anything but the defaults for this right now. We're going to switch over to the view mode, and we're going to go and look at the layers. And so we'll switch over to the layers. And then what we'll do is we'll hit the prepare button. And what that will do is it will prepare it, and I'll push the middle mouse wheel, and then if I turn it, I can then see how this is set up. And so when I had the build plate adhesion set for skirt, you can see that it kind of sticks out here a little bit. And you can also see then how the layers are going to be supported. And so this is our support material. Because it can't print in the air, technically it can do some air printing. It's called bridging. And then it's going to print it in 24 layers. And so we can come down and look at how each of those layers is built. Then we can come back up, take a look at it. Everything looks decent. So what we'll do is we'll save this to our removable drive. And then I can take that drive and eject that and put it into the 3D printer. Okay, that ends how to take the software and open the file in AutoCAD, bring it into the slicer, and then prepare it for printing. I'm going to pause the video and see if I can get a network connection and see if I can demonstrate that as well. Resuming. Okay, so I was able to get a network connection to my Dremel 3D45. As you recall, we prepared this by going through and setting up our slicing options. And so now it's ready to print over the network. If we want to verify our slicing, we can come over here and go through the slices. Now this one has got a lot more layers, and so I noticed that it's got a high quality setting. I'm going to dial that back down to a 0.3 millimeter and then re-slice it. Once we have sliced it, it will give us this information as far as how long it will take and the file name that it's going to use. So if we were to save this to a USB, we could save it to a removable drive. But if we print it over the network, there's no need for that. It'll just go directly over the internet. And so when we're connected over the internet, we'll see our 3D printer. They have cameras built into them. And so we can see this is the filament and this is our build plate. We'll come back to our prepare button and then we'll click on print over network. So it'll send that file over to the printer and then it will start to warm up the nozzle and it will then bring the platen up or the build plate. And this little sensor here will check the level of the build plate. And so it'll take, I believe it takes 6 or 9 measurements. That would be 2. So that will be 9. So it'll take 3 measurements to make sure that the plate is perfectly flat. Because if the plate isn't perfectly flat, then the layers won't be properly aligned. It will be crooked. I'm going to pause while it continues. So once it's taken the readings, then it will heat the filament nozzles up to temperature. So we're waiting for the nozzle temperature to get to 230 degrees Celsius. Once it gets to 230 degrees Celsius, it will begin printing. And so the platen is raising, or the build plate. And it's now extruding the first layer. You want to check for good build plate adhesion for the first layer because it's the foundation for all the rest of the build. And we'll come back and check on this. We can see the time remaining is 47 minutes and 59 seconds. Okay, so as we can see, we're 3D printing our COVID face shield, and this completes lab number 1.